Hey everyone, my name is Abe, and today I'm going to be talking about building intelligent applications with graph based RAG on Postgres. If you're someone who's already built a RAG application or want to learn more about making your RAG apps more accurate, this is a great talk for you. So let's get started. As I told you all already, I'm Abe. I'm a product manager on the Postgres AI team working at Microsoft, and I have previous experience working in Azure AI as well as Databricks. So you could say I've been in the AI trenches for quite a while. And obviously, I had to hop on the trend and made a Studio Ghibli version of myself as well. If you want to know more about me, all my socials are on the side, and go ahead and follow me. So let's go into the presentation. So, question I have for y'all is: has ChatGPT or Copilot ever given you an insufficient answer? That happened for me just today. So I asked ChatGPT. I said, "Hey, you know, what talk is Abe Amargbe giving at Posette?" And it answers super confidently. There's no public information about me giving a talk when I'm here in front of you giving a talk. And it's not just me that's running into these kind of issues or hallucinations with ChatGPT. These are articles I've picked up all over the internet over the past uh, few months. And the one I like the most is basically saying Gen AI accuracy problems aren't going away anytime soon, researchers say. What I want to address today is help us solve that exact problem. How do we improve the accuracy of our Gen AI applications? Today, I'm going to walk you through building an AI legal app directly on Postgres. We're going to start talking about why Postgres. Then we're going to talk about the legal data set I used. Then we'll talk about the evolution of simple search all the way to vector search. Then we'll talk about basic RAG. Most of the folks might already know about that, but let's level set. And then we'll talk about where RAG breaks and how we can solve those problems. And lastly, we'll talk about advanced RAG architectures. So let's get going. First, why Postgres? The main reason for Postgres, I'm not biased here, trust me. I know I'm the Postgres team, but a big reason for it is Postgres is actually the number one database for professional developers. So the real reason it's super popular right now, especially in the Gen AI space, is because Postgres is super flexible. It supports a lot of different extensions that help with building Gen AI applications. Things like AI model extensions. So if you're using Azure, you can easily use Azure AI extension. You can work with vectors using PG vectors. You can work with unstructured data using JSON-B format. You can also do graph directly in your Postgres database, which I'll show today, all inside Postgres. And on top of that, you get a really vibrant OSS community to lean on and get feedback from, and also get some answers from. So it's a really good place to start building a Gen AI app, especially as the market is moving super quickly now. And you have a backend database that can also evolve with how the market is moving. So we dive right into building this legal Copilot app. So imagine you're a legal researcher or you're a lawyer like in the state of Washington, and you want to help your clients answer simple questions about, tenant rights or property disputes. If a client asks you, "Hey, water is leaking from the apartment above. Like, how do I solve this? What is the precedence to kind of either sue my landlord or get this fixed?" This app will be designed to help solve that. So let's start. So first, we're going to talk about the data set we used for this. The data set we used the US case law data set, and we took a subset of just Washington state. In this data set, we had around 100,000 cases, around 7 reporters, and up to 500,000 pages scanned and put in JSON format. So how it worked is we took the JSON blob of this data, we ported it over with JSON-B format to Postgres, and we created a structured table of the names of the cases as well as the opinions. Right. So now we can easily search this data and do more things. So now let's go through how we search this data and some typical methods most people use. So how do we start using this data and searching this data? The first thing, most folks might just use I like. So the problem with I like is, let me just show you right here, is if you're using I like, you can see you kind of do a regular expression here to figure out, oh, water leaking from the apartment above, but inevitably you have zero results because there is no opinion from these cases that have those exact text. So this doesn't quite cut it. The second thing you may do is you might say, hey, you know what? Let me try use full text search to find this. But you might run into a very, very similar issue where, you do the full text search. I create a text search column. I did my full text search. And again, only one result, not much better than I like. There must be a way we can use to kind of solve this issue. Like, how do we solve this and what can we do to help kind of find data related to water leaking from the apartment above or something your client asked? This is where we introduce vectors, right? So, what exactly vectors are is imagine a vector is just what I say is like a word represented as a number in the graph space. So, as you can see in the picture, imagine the word dog and then the word cat. Both of them can be represented as numbers in the graph. And if I did a similarity search, with the similarity search, I can use an algorithm to find how close dog is to cat and then find, hey, no, dog is actually related to cat because they're around the same space. This same principle is used throughout vector searching, and we can use this to kind of solve this problem and get more relevant answers. The way it works is we take the word dog or whatever word or whatever sentence and we pass it through a model. So there are many deep learning models out there. One popular one is Word2Vec, but there's also ones from OpenAI, Cohere, and a bunch of other folks that support different input formats as well as different dimensions. So you can take any word or sentence and convert them to vectors. If you want to learn more about vectors and how things appear in different space, I would super recommend going to it's called projector.tensorflow.org. You can go ahead and you can see exactly, where words appear related to each other. So you can see in this chart, I can see here dog, it's kind of related to rat, it's kind of related to all these other animals. So it's a good way to help you kind of visualize what's going on with your vectors. When we go to Postgres specifically, what we can do is we can take all these words and all these opinions, we can convert them to vectors and store them directly in Postgres. And the way we can do this is with two main extensions. The first one being pgvector. So what we'll do is we'll use pgvector, as you can see here, is we're going to use pgvector to define the vector type. So this is a vector type that has 1536 dimensions. So the opinions are saved in those dimensions. And then as we store each opinion, we use Azure AI to create the embeddings, so the vectors, to store in the table. So this is a pretty seamless way to kind of set up your vector search. And you can use another replacement if you have for if you're not using Azure, there are a bunch of other extensions out there that can do the same AI thing. So basically how it work is if I do that same search that I did before, so I did the same thing with vector search. Now I'm getting a lot of cases that are related exactly to what I'm talking about when it comes to water leaking from the apartment above. So we're getting a lot better accuracy now. We're getting a lot more results. So it's pretty cool. So now we're going to go on to add in this vector search into a basic application. So most folks already know this. You can use vector search with RAG. And before I go more into it, let me just level set on what exactly RAG is. Simply put, RAG is retrieval augmented generation. And all it is a technique that takes your data. So for this case, my legal data, it chops it up into little chunks. It puts it as context for our prompt, and then we send the prompt to the LLM to give an answer. So this is where we can use vector search to get the right context, pass it to LLM, and hopefully get more accurate answers. The only problem that we see with RAG today are two main things. The first problem being scale. To efficiently scale these vectors to kind of store them in roughly when you have like a million vectors in Postgres, it's hard to keep scaling these and also getting good performance search results. So you probably need something else to either index or do more. And for accuracy, it's another big problem. As this data scales and you have more data in your data set, getting the most accurate response becomes harder. So how do we solve that first problem? Scale. So we can solve scale with vector indexing. There are two big vector indexes on the market today. One, IVF flat, and the other, HLSW. IVF flat is a clustering algorithm that will cluster all your vectors into different clusters. So when you do search, it's easier to find them in specific cluster. The only downside to IVF flat is that every time you add new data, you need to reindex because you need to put the data in the specific cluster. So kind of a disadvantage there. And the second one is HNSW. This is a lot more efficient. It creates a multi-layer graph that has, all like if you construct that graph, you'll be able to find things at different levels of the graph. So when you do a search, if something is on the top level, you can hopefully get your results a lot faster. But these two things, they have their pros and cons. Generally speaking, IVF flat is usually best when it comes to large data sets, but super low dimensionality. And HNSW is generally good for when you have smaller data sets and high dimensionality. Like I said, it has different layers that are created, so smaller data sets are probably better here. So how do we solve it when we have both a large data set and high dimensionality? When we scale up to millions and we're using maybe like OpenAI for embedding. That's where we introduce the DiskKNN vector index algorithm. Basically, what this is DiskKNN is a highly performant vector index algorithm developed here at Microsoft. It's basically years of Microsoft research and has been used by folks like Bing, Office already using DiskKNN to optimize their searches for those applications. And we brought that power right into Postgres. The way it works is it takes the vectors, it stores them as compressed vectors in RAM, so you can have super quick search speeds, and then it stores the full vectors in your disk. So when you do the first search, you can go ahead and retrieve you retrieve the vectors that you found from disk, and you get more accurate answers. What this basically means is since your graph is stored as a compressed data set inside memory, it has a much smaller memory footprint. So that results in a lot of cost savings. Let me show you. So basically, if you're using DiskKNN versus HNSW, you can see here, I have two tables, identical tables, both around 6 gigs. And then when I did my indexing, you can see right here that HNSW index is 150 MB versus 3.5 gigs roughly. It's roughly 25 times smaller than if you were to index with HNSW. This would result over time in better search speeds at a smaller compute size. So because you can store the graph in a smaller compute or smaller resources, you should be able to do more with this index. And the great part about this is DiskKNN is as easy to use as other index algorithms. All you have to do is index with DiskKNN, and that's it. So now we move on to the second problem. The second problem is around accuracy. So how do we improve accuracy as we scale up? And how do we improve it? We're using some advanced RAG architectures. So the last step of this, we've gone through all things. Now we want to go through these advanced RAG architectures and how exactly we can, improve your vector searches. So first thing first, there are two main ways that you can improve accuracy when it comes to GenAI applications. One, you can use basic RAG. So let's think about things like chunking strategies, think about, using bigger embeddings. Maybe you want to do some query rewriting, maybe do some hybrid search, so on and so forth. And they're also advanced RAG solutions. So you can do things like semantic re-ranking. Basically how that works is first pass, you do a vector search, then you re-rank based on the semantic meaning of the words you return, and hopefully you get better accuracy. Secondly, you can do hierarchical summarization. Basically, all it is it looks at all your information, it clusters it, and creates a tree structure to make search faster and easier, and also more accurate. You can use Graph RAG. Basically, what Graph RAG does, it uses the relationship with your entities to give you better answers, or just use an agentic system. And the way agentic system works is they rely heavily on different tools to supply the right context to give your thing the right answer. We're going to focus today mainly on GraphRag and how we can use GraphRag to improve accuracy of these apps. So super high level, what is GraphRag? GraphRag started at Microsoft check the project GraphRag, it's there. So basically all it is it takes all your data, does some graph extraction, does some entity summarization on your data, and then when a user asks questions, it creates a graph query and it retrieves the right information. So that's how it is. And today I'm going to walk you through how you can use GraphRag for this legal case data. So for the legal case data, what we did is we For the graph extraction, we use the pre-extracted relationship in the graph. So basically how cases relate to one another. And then entity summarization step, we didn't need to because we're just using the relationships between the cases. And then lastly, we used Apache AGE for very specialized graph queries. So if you don't know about Apache AGE, you should definitely check it out. It supports graph write in Postgres. It supports Cypher searches, hybrid searches, and many different things. And just to quickly show you what that graph looks like, you can see here, if you had a bunch of different cases, for example, case 5 references case 3, which references case 4, so on and so forth. So if I were to search search here, I can find the relationships and see which one is most relevant. So how do we use this advanced graph rag technique to kind of improve search? So I'm going to go here and kind of show you what I mean. So basically, what the question someone may ask is a question like this: like, hey, look, there's water leaking from the apartment above, and I want to know the prominent cases to kind of support this argument. So the only way we can do it today easily is with graph. So what we can do is we can look at the relationship of all the cases, and you can see here what I'm doing is if a case is related to another case, just count the cases. So what I want to do is count all the cases that are related and return the ones that have the most relations. So how I use that today, especially in Postgres or a graph query, what I can do is at the top, what I just showed you, you can see here I have a graph query, and basically what the graph query is doing is what I said. So I'm checking for any references to a node, and the node being the cases, count all those nodes. And then at the bottom part here, I'm doing something called RRF. Basically, what that's doing is it's reciprocal rank fusion. It's combining the results from GraphRag as well as vector search, combine them to give me a joint answer. And then on the bottom, you can see it's returning back um, the best rankings on both. So you can see this case at the top is the best because it's one of the highest with vector search and also one of the highest with GraphRag. So it can go ahead and say, hey, this is a better solution for you. So what I want to do is I want to show you what this looks like in practice. So I'm going to go ahead to a quick demo of this. So right here, I already have an application. I already have a vector search application, and I run this vector search application. And I asked my legal copilot, hey, water leaking from the apartment above. What are some prominent some prominent use cases? So it says some prominent use cases, and then it pulls out some reports here. And I have this handy tool here. It shows me if it retrieved the right information to answer this. So you can see here, what you're looking at is you can see the recall is around 40%. Because what's happening is you can see the gold balls are what it should have retrieved, and the green is what it actually retrieved. Vector search was only able to retrieve things at 40% accuracy to answer this question because it didn't understand what prominence meant. If I switch this application over here to GraphRag, I can try and see, let me just go over here. I can see the exact same search done with GraphRag. We can check it out here. So we can see that this exact same search, when I used GraphRag, there are a lot more relations. So you can see all the bigger balls right here have been selected with GraphRag because what happened is after it did the vector search, it did a re-ranking based on whichever ones had the more relations. So because it's more prominent, those came up first. So this is how you can kind of use GraphRag or graph relation to kind of improve some of your search results. So hopefully that makes sense and it kind of shows you how. You can kind of see it here. I'm gonna skip that. And yeah, so basically, if you want to build this Copilot, legal Copilot yourself on your own time with Postgres and with all the things I showed, go ahead, check out our solution accelerator for Postgres. It has this legal Copilot app plus the UI. You can use the US case law dataset. It's all in the repo. You can test that out. And you can also read the blog about it and learn more about how to use GraphRag to build your applications. And lastly, I'm going to kind of leave you guys with one thing. Again, I'm not biased here, but I really do think that Azure Database for Postgres is a super useful tool that gives you all the same functionality you will get in Postgres, um, as well as any enterprise applications. Everything I mentioned today can be done in open source. But if you're working in enterprise and have some enterprise requirements like scaling up or high availability, it's super easy to just drop right into Azure Postgres and do the same things. And then lastly, I'm going to leave you with a bunch of resources that you can use, such as you can go ahead and see how to implement agents with Postgres. You can also go ahead and see other solution accelerators we have, like semantic re-ranking, like I talked about, the advanced architectures I talked about, as well as other accelerators that can help you speed things up. And to keep up with the team and learn a little bit more, please check out our blog. And yeah, you can learn more about this. So thank you guys so much for listening. I'm so happy you guys took the time to listen to this whole talk that I had. Hopefully you can explore and you can see that building this legal copilot, that's something that's super or more accurate with your data, is possible with GraphRag, Postgres, and a bunch of other architectures that I described. So hopefully we see you guys build it, and make sure you follow me on GitHub or X. Thank you.